Hi there, it's Ms. Heaton signing in to talk with you today about naming acids and bases. This is a super important topic for many reasons, one of which is illustrated here by Johnny. This is a little rhyme you may have heard before. Johnny was a chemist's son, but Johnny is no more. What Johnny thought was H2O was H2SO4, which may not make a lot of sense right now, but by the end of today, you should know what H2SO4 is and know just how dangerous it is going to be if you actually drink it. Let's start, though, by talking about bases, because bases are a little bit easier. We'll go through naming bases, then we'll talk about naming acids. You actually know how to name strong bases. In fact, let's just dive right in here. NaOH, what is that? Well, that's going to be sodium, because the first element is sodium, and then OH is that polyatomic ion hydroxide. You know the polyatomic ion hydroxide is OH, and that's present in all strong bases. Okay, how about MgOH2? Well, that would be magnesium hydroxide. Not too bad, right? Where it gets a tiny bit trickier is with the name going to the formula. If I give you calcium hydroxide, you know that there's a calcium in there and that there's a hydroxide in there. But many of you have been forgetting to crisscross your charges. This is where it comes into play. If you look at the periodic table, you know that calcium has a +2 charge. Hydroxide, you've memorized, has a -1 charge, so you'll need to crisscross those charges to know that the calcium hydroxide formula is CaOH2. Okay, aluminum hydroxide is going to follow the same trend. Aluminum is +3 because it's here in this column, and hydroxide is still -1, so we'll crisscross and get AlOH3. Not too bad though, right? Okay, let's talk about naming acids. One thing we know about acids is that they all have at least one H+, one hydrogen ion, cation in there. And then they also have an anion, something with a negative charge. The name is going to be determined by what kind of anion they're with. There's 3 options, and I've color-coded them here for you. If the anion is a single element, like in H2S, there's an S anion in there. That'll be one system. If it's a polyatomic ion whose name ends in 8, like sulfate, SO4, or if it's a polyatomic ion whose name ends in "ite," like sulfite. Those are the 3 sets of naming systems that we're going to use. Now wait a second, you're like, I don't remember which ones end in 8 and "ite." Well, if you don't remember, you need to bust out those polyatomic ion flashcards that you made back in first semester and relearn them. For your convenience, I have listed them all here, so if you don't know them, copy them down and study them. Moving right along, let's look at the 3 naming systems for acids. The first one is if you have an acid that just has a single element, no polyatomic ion in it. The name format will always be hydro-something-ic acid. And that something will depend on what the anion's name is. For example, H2S. The anion here is the S -2, and we know that it's -2 for a variety of reasons. First of all, from its column on the periodic table. Also, because it takes 2 hydrogens to balance out its charge. The name of this would be the sulfur ion. Actually, though, we would call this the sulfide ion, because if it's a single element, we'll put the IDE ending on there. But the root of the anion's name here is sulfur. For some elements, we'll take off the last part, but for sulfur, we keep it all on there. We'll do an example of that later. So since the format should be hydro-root-ic acid, this will be hydrosulfic, or oops, we should keep it all, sulfuric acid. Okay, so that's if it's a single element. If you have a polyatomic ion whose name ends in 8, you're going to have an acid name format that's something like the root-ic acid. So an example of this would be H2SO4, because the anion there, SO4 2-, is sulfate. It ends in 8. So the acid will be sulfuric acid. Hey, do you recognize the H2SO4? That's what Johnny drank that killed him. And here's why. I did a little research on sulfuric acid. It is highly caustic. It has a strong acid nature. It decomposes muscles. Yum. And it will decompose fats as well. So his insides were probably being decomposed. It's highly exothermic, so he felt a little burning inside his stomach. It causes a chemical burn and also a thermal burn as it releases that heat. And it can dissolve tissues and leave a translucent but black solution behind. So it's very important that you know that H2SO4 is different than H2O. Don't mix those up. You will have very different consequences if you drink them. Okay, third and final naming system for acids is if you have a polyatomic ion that ends in "ite." So for those, you'll take the root of the polyatomic ion's name and put OUS, or us, acid, on the end. So an example of this would be the SO3 2- ion, which is sulfite. The name of this acid would be sulfurous acid. Okay, notice that if we look at all three of these naming systems together, two of them end in ic. One of them starts with hydro. So if it's a single element, it starts with hydro. It usually has an ic ending unless the polyatomic ion ends in OUS. Let's try going the other way, because sometimes people get tripped up doing that. So if you look at the hydrochloric acid, you know that if you see that hydro prefix, that it came from just a single element. So the first thing you want to do is identify the anion. In this case, it'd be Cl, excuse me, Cl-1, and you know that from the periodic table. Then we're going to crisscross the charges when we put that with an H+. H+ has a +1 charge, Cl is a -1, so that will just be HCl, hydrochloric acid. Chlorous acid, the OUS ending means that it comes from whoops, I spelled that wrong, chlorite, which is ClO2 -1. So if we put that with an H+, they both have a +1 charge, so no crisscrossing needed. That'll just be HClO2. That'd be chlorous acid. And then chloric acid would come from chlorate, which is ClO3-. So put that with an H+. Whoops, sloppy handwriting. Please excuse that. That'd be HClO3, chloric acid. Okay, folks, that's naming. Why don't you try a few on your own here? Oh, wait, I forgot. I have this beautiful flowchart from your book. It's a little bit blurry here, but check out page 133. This will kind of give you a visual of the naming rules that we just discussed. Okay, what I'd like you to do now is copy down this table, hit the pause button, and then fill in the chart based on what you know to see if you really know what's going on. Have you tried it? If not, hit the pause button. Do it now. Okay, folks, here's your answers. So take a minute to check those. The one I want to talk about is this carbonate one. Carbonate is the ion CO3 2-. So you know that if it ends in 8, the name of the acid has to become ic on the end. So that's going to be carbonic acid. And in terms of crisscrossing, since the CO3 has a -2 charge and you're putting it with an acid H+ that has a +1 charge, when you crisscross, you should get H2CO3. If you have any questions about those, please contact your teacher. Come to class tomorrow ready to ask questions and practice. Happy naming, and don't drink any H2SO4.